Okay, well, I'll walk you through this together, okay? But if you have the handout, I would love if you do this on your own first, okay? The first one is the catalytic, acid catalyzed hydration, go through Markovnikov, so the OH group will go on to the more substitute carbon, okay? The more Markovnikov carbon, that one. This is not a chiral center, so you don't have to do anything on here. Just leave it like that. You can put wedge and dash, but I mean, it doesn't matter here. Next one, hydroboration oxidation. So this one goes syn addition and also anti-Markovnikov addition as well. So boron will interact with that carbon, the less substitute carbon, okay? And then will become OH later. So you get wedge and dash like that, all right? Remember, this is syn addition, so OH and hydrogen on this wedge, and then dash and dash. But again, this is not a chiral center, so you can just ignore the hydrogen and just put the methyl straight up. You can do that too, okay? All right, draw just something like that. Next one, we have, was it oxymercuration, demercuration, does not go through a carbocation, no rearrangement, but still give you a Markovnikov product, that one. Same one with the first one. Next one, let's say this is catalytic hydrogenation. So the hydrogens, two hydrogens will be added onto an alkane. I mean alkene, making an alkane. No stereochemistry, just leave that. All right, next one is an anti-dihydroxylation. The first step, we're adding a peroxy acid, meta-chloroperoxy benzoic acid, making an epoxide, okay? Wedge and dash and dash. Water will attack on the other side, so attack on dash, and this one attack on wedge. Okay, so you end up with this guy. There's a chiral center right there. Be careful. Next one, let's see what we have. We are doing the hydrohalogenation. Okay, so we're adding hydrogens and then a chlorine. All right, so go through a carbocation and go through follow Markovnikov's rule. Chloride will be on the more substitute carbon. Okay. Next one, this one anti-Markovnikov hydroboration. Okay, so bromine will go to the less substitute carbon, adding peroxide, adding light. That one, wedge and dash. That's a chiral center now. Next one, halohydrin formation. So adding bromine, you get bromonium ion, wedge and wedge, or dash and dash, this guy. And then the nucleophilic solvent, water, there's a bunch of them, okay, will beat bromide, attacking the epoxide first, bromonium ion first, okay? Attack from dash, you get dash oxygen right there. Attack from wedge, you get wedge oxygen, but it's not a chiral center there, so you don't have to show it. Okay, bromine, this is wedge, stay wedge. This is dash, stay dash. Lastly, all right, so we have bromine with the carbon tetrachloride. This is not a nucleophilic solvent and does not participate in the reaction. So adding bromine, you get bromonium ion first, just like that. And no other nucleophile can compete with this bromide. So bromide attack. You get the same thing, but two bromines on it. That's it. Okay. All right, we got a few more to go. Next one, all right, this one ozonolysis. So just cut the CC double bond and add oxygen, okay? I don't know how to explain this, so that's all I can explain. So we get acetone on one side and acetaldehyde on the right side. Look like that. This is acetone, this is acetaldehyde. We'll talk about naming later, organic chemistry too. Okay, let's see, next one, osmium tetroxide and NMO. This one dihydroxylation, syn addition too. So you get OH, okay? So you get wedge, is it syn dihydroxylation, so you get wedge and wedge, but again, this carbon is not a chiral center, so you don't have to do anything about it, just put OH right there. This will become a chiral center when you have added the oxygen, so you're gonna be wedge and dash. One. Okay, like that. Again, you don't have to show wedge and dash on here, you can draw just like this, 1, 2, and 3, here we go. You can draw just like that, it's fine. Now, next one, permanganate. Cold solution in basic solution. This one the same, different recipe, but give the same result. Okay, with the osmium tetroxide, same thing. Okay, lastly, last one. So we have this one, anti-dihydroxylation. Okay, adding peroxy acid first, you make the epoxide wedge and dash like this. Then we pop the ring open with an acid. Water will attack on the more substitute carbon. Okay, this is anti-dihydroxylation. apparently that's the only chiral center, so you get the same product right here. Okay, if this carbon and that carbon right there were to be a chiral center using anti-addition. All right, that's all you need to know. Let's do the exam question. Let's go.